All right, welcome. This is the AP Physics Momentum Test Review Solutions. This is for the multiple choice. Here I'm covering questions 13 and up to questions 24. Okay, we have 13 here. You could read the scenario. A small car crashes and meshes into a large truck. And they asked us about what is the magnitude of the momentum change. Okay, so I can visually show you the objects if you would like to see it. So here is a small car, and it's getting hit by a bigger truck. Okay. Now, here, what's going to happen when the momentum change during the collision? Once they hit, right? Once they hit here, they will have to experience the same momentum change. So whatever momentum, so here they had a P, this momentum, let's say this one had a momentum coming in here at, let's say, 5 kg per meter second squared. This one was coming in at 10 kg, right, times ms squared. Okay, in total, the total here would be equal to what? Minus 5, yeah, kg meter squared, because again this is going to the right, this is going to the left, that's why it's a minus. That's the initial picture. The final picture, the total still has to be what? Negative 5 kg times meter squared, because here the momentum is conservative. So momentum is conservative. Okay. Their speed might change, but the total momentum is still correct, right? So the small truck experienced, nope. So it would be the small car and the truck experienced the same magnitude of the momentum change. That is correct. Okay. The small car experienced the greater magnitude momentum change. No, it would actually experience a greater, maybe like a velocity change, right? The truck experienced a greater magnitude in momentum change. No, it might experience a velocity change, a greater velocity change. Directly proportion, nope, that wouldn't work. And inversely proportion, nope, that wouldn't work. Okay, 13 would be E. Okay, let's look at 14. Here we have the rocket that is exploding into certain pieces. They're asking for the change in the lighter garment. So here, let's just draw the picture. Here's the rocket. All right. Okay, and it breaks up into smaller pieces. So let's say here it had a momentum, right? P is equal to 10 kg times meter second squared. So in the end, even if it breaks up into small pieces, like it has this piece, okay, and it had this piece right here with the other wind pieces right here, right? The total here still has to be 10 kg times m meter squared. Okay, their momentums has to be the same, okay, but the magnitude of the momentum change of the lighter garment. So here, notice, so this is going to be broken into two pieces. So here you could write this as just m plus like big M plus the other M, right? Because there's different pieces to it, times equals to velocity. Here, they're at individually now. So it was just like M plus V plus MV plus MV, right? There's different parts to it, okay? So the magnitude of the momentum change of the lighter garment is blank, 25 times as great. One is heavier, no. the 1.5 as great as momentum change of the heavier fragment. Nope. 5 as great. Nope. The same momentum change for the heavier object. That would be, or the, okay, it would be the same. The reason why it would be the same is because here it would be as great as the momentum change. All these questions are wrong. It could be its velocity is changed, but its momentum is actually going to be the same. Okay, so let's say this had let's say a momentum of 10, and this is 10 now, right? This could be 5, and this could be 5. Okay, so do you see how it went from 10 to 5? That was a momentum change. Okay, even though this one's heavier, right? This one is heavier. Sorry, it has more mass, not heavier, because it has more mass, right? 25 times more mass. That doesn't mean that it's going to have less momentum, right? It's going to have more mass, so its velocity is less. Okay, here it has less mass. It's going to be the same momentum, so its velocity is going to be just is greater. Okay, but the momentum change of it is going to be the same. All right, 15. Right. So what happens during this collision? Right. So let's just look at it from a momentum point of view. So here, please understand momentum is equal to mass times velocity. So I compute it. The momentum here is going to be, I'm just going to ignore the units. I'm not going to write the units, but please understand it's kilograms per meter squared, kilograms times meter over second. And if we do the momentum here, it's 1.2. Momentum here is P equals 2.4. Momentum here is P equals to 8.4. Please understand, I'm going to treat whatever goes to the right and up as positive. So here the net P is equal to 6. The net P here, which is momentum, is also here 6. Okay? So here we would call this a perfectly inelastic collision because momentum before and momentum after, momentum initial is equal to momentum final. Alright, let's look at 16 here. A rubber ball bounces off a ball with initial speed, reverses direction. As a result, what is going to be conservative here? The momentum of the ball, let's see. Here's the ball. It hits a wall. It goes in here at MV. It's going to come back out here at what? Negative MV. We know that the change in momentum, right? Change in momentum is going to be MV final minus MV initial. So that would be MV minus negative MV. This would be 2mv. So this is not correct. It wouldn't be the momentum of the ball. This proves it. Okay. Both the momentum and the kinetic energy of the ball. Nope, that doesn't make sense. The momentum would be off already. Okay. What about the kinetic energy? Let's see if kinetic energy is conservative. Okay, so it goes in here and it hits it at 1/2 meters per second squared. Right? Then it also comes back at what? The same thing. 1/2 meters per second squared. Okay, so you can sort of set this up, but you should notice that the energy initial is going to be equal to the momentum final. So the kinetic energy here is also conservative. If you approach it from this question point of view, you could see that all you have to do is move this, set it equal to 0. So this is going to be moved over to the other side. You're going to end up getting V of your second object is going to be equal to the V of the first object. Okay, so the velocity in is the same thing in the velocity towards the wall is the same thing as the velocity away from the wall. Okay, because it hits it. That's why it bounced back. Alright. Okay. Let's look at 17 now. If you double the momentum of a gas molecule, by what factor must you increase its kinetic energy? Alright, so here we have its momentum is P equals to mv. We double it. So we double this, mv. If we double this, I'm going to keep mass the same. If we double this, the v also has to double. So v doubles as well. Okay. Then we can look at the kinetic energy. The kinetic energy is 1/2 mv squared, but we know the new v is going to be 2v. So 2v. This becomes 1/2 m4v squared. Okay. So this 4v squared, if you look by the factor, because the original, so this is the new one, this is k new. If you look at k new, which is 1/2 m4v squared over ke old, which is just 1/2 mv squared. 1/2 cancels, 1/2 cancels, the m cancels, the m cancels, the what? 4 v squared cancels. The only thing left is a 4. So we would say it's done by a 4. Okay, so if you double the momentum, the kinetic energy is going to go up by 4. Okay, so the momentum, okay, relationship with kinetic, right, is that if this doubles, if this goes 2, this becomes 4. If this becomes 3, this becomes 6. If this is 10, this is 20. Okay, if you half the momentum, the kinetic energy is going to be by 1/4. Okay, if you 1/10 the momentum, it's the kinetic energy is going to go down by 1/100. Okay, this is its relationship. I think it's called squared relationship. 18. What is the positive direction is going to be to the right? Yep, that's right. Good. And what is the total momentum? Let's calculate. Please understand momentum is equal to mass times velocity. So the momentum here is plus 40 kg times meter over second. This is negative 60 because again it's going to the left. This is going to the right, so this is positive 60. Okay, so 40 minus 60 plus 6 is equal to negative 14. Please understand the units. For momentum, it's kilograms times meter over squared. Okay, so let's look at the next questions. Okay, 19. A ball is going to be traveling horizontally at that. It hits a ball, rebound that. What is the magnitude of the change in the balls during the rebound? All right, so here's the ball. It hits the wall. Then the ball goes back. There's an MV going here, and there's an MV going this way. Please understand this is going to be minus because I treat anything up and to the right as positive. So here, okay, a change in momentum. Okay, I'm just going to write it as delta P is equal to M V final minus M V initial. Okay, so in this case, the starting momentum, the ending momentum, what is coming in is a 2.5, right, and times 10 kilograms, and what was going out was a 19 times 10 kilograms, a point 10 kilograms, point 10 kilograms. All right. So if you work out the math, you're going to get so what you're going to get here is the momentum is that you're going to see it coming in the wall with 2.5 because originally it's 25, right? So this becomes 2.5. Understand that. Comes in with 2.5 kilograms per meter second squared, then goes out at negative 119 kilograms per meter second squared. These are all momentums, okay? It comes from here. How do I get this? I get P is equal to mv. The mass here was 25, and the ball here, the mass was 0.10 times 25. What's its velocity? Same thing here. 0.10 times what? 19. Okay. So what we have here is the original, which is the final. I think I made that negative 19. Okay. And that is going to be minusing what? A 2.5. This gets you a negative 4.4. And here it's asking for the magnitude, so I can just take the absolute value. Okay, so delta P can just be equal to 4.4 kilograms per meter second squared, which is just going to be D. Let's look at 20. Okay, here's the ice skaters. Here, here it's going to be pushed out with the 45 kilograms times 0.375. That is what its momentum is. So the momentum here is 16.875. If this is pushes to the left, this also has to be pushed to the right with the same value, 16.875. Okay, please understand the sign is different because it's in the opposite direction. But we know that they have this is a 60 kilograms, so the mass here is 60 kilograms. What is its velocity? So all we have to do is set 16.875 because that was its momentum again, and the momentums are the same because they push off each other. Its mass here is 60, its velocity is v divided by 60 divided by 60. The velocity here is going to be equal to 0.28 meters per second. Okay, here they're asking for what is the change in the momentum. Please understand the change in momentum can be defined as F times delta T, or in this case, F here. This is F, and to the right here, it's just going to be considered delta T, which is the change. So we can find the area here. The area here is going to be 5 times 10, which is going to be equal to 50 here, and we know that the area here is going to be 1/2 times 5 times 50. Right, and we got here a total of 75, but you see how it's negative. Okay, so the answer here would be negative 75 kilograms per meter second squared. Right, please understand that this is a 75 kilogram is basically in the opposite direction because it's a negative sign. Okay. 22. Same here. What is the magnitude of the impulse? Please understand what impulse means. Impulse is defined by the change in momentum. So here you can just write F times delta T is equal to mv final minus mv initial. Okay. All right. So please understand that it's coming in with a v initial, but this part is the part that's coming in is going to be with the vi sine theta, and here it's going to come out with vf sine theta as well. Okay, so please understand it's f it is F delta T is equal to, the mass is 20 kilograms. What is it? 20 grams, so it becomes, we gotta convert this into kilograms. This needs to be converted to kilograms, okay? So, let's see. Hmm. 20 grams times kilograms. How many kilogram? 1 gram is the prefix gets, wait. 1 kilogram. 1 kilogram is 1,000 grams. So if you do that conversion, it should get you 0.02 kilograms. So this should be 0.02 times V final, which is going to be three. What is it? 250? No, 320. Plane, blah blah blah. It bounced off at the same angle, but at 3. So final is 320. 320. But this is going to have a sine theta part to it. It's going to be minus 0.02. Okay, times the initial, which is just 250 sine theta. Alright, if you plug in those values, oh, you got to make sure you divide this by, right, delta t, right? Then once you do that, it would just be F. Okay, on the bottom, remember the time, it is what? What would be the time here? It says a what is the magnitude of the impulse on the plate? So, oh nope, you wouldn't. You would keep the time, okay? Because this is what you're looking for. This is the impulse. Okay, so if you do that, you should get an answer of 6.7. Right? Let's look at 23. Here, a golf club is being exerted. Right? There is a force, a mass, and it has a time component, and the speed of the ball before it leaves the tee. So, make blue here. So please understand that force times delta t is going to get you your mass times Bf minus mass times V initial. Understand the ball was initially at rest, so this goes automatically to 0. So it disappears. Right? So here you're trying to solve for what is the speed of the ball just before it hits. Before what? The club is in contact with, what is the speed of the golf ball just because it leaves the tee. So you're looking for V final. So divide this by M, divide this by M. You have V is equal to, what is your force? That is 1,000 newtons. Times this by the 1.8 millisecond, right? This should be milliseconds. This should be second, right? Then how many millisecond is in a second? It should be 10 to the milli. Let's see. Millisecond. I have by 3. So there should be 10 to the 3 here. Right? And that's 1 second is 10 to the 3 milliseconds. Right? So this becomes 1 times 8 times 10 to the negative 3 divided by the mass, which is just 0.045. Work this out, you get V is going to be equal to 40 meters per second square, meters over second. Here you have 24. They're asking you for what is the magnitude of the impulse. And again, what is impulse? Impulse is just m delta v is going to be equal to your f delta t, right? Understand the way we see this is mv final minus mv initial. This is going to be equal to basically impulse, right? F delta t is just another word for impulse, right? So here we actually know what the mass is. We know that the mass is 34. Final is 90, right? Minus the 81 times 0.5 is going to be equal to the impulse. Work that out. You're going to get the value of 32. Okay. All right. So there you go. Those are all your solutions.